Welcome to this course on mechanism and robot kinematics. In this short video, I am going to give you a brief justification, an overview of what we are going to study and why we are going to study. The second question is possibly to be answered first, why we should study kinematics of mechanisms and robots. You know, with automation, you require lot of specialized mechanisms and robots. For example, in the automotive industry, if you look at the automotive industry, a large part of their assembly line production depends on robots. This is for better quality, more efficiency and continuously working for repetitive kind of jobs. In aerospace industry, for example, they regularly use robot assisted or mechanism, specialized mechanism assisted devices. In the automotive industry, for example, bus doors, if you look at bus doors nowadays, which are automated bus doors, they are not simple hinges, they are mechanisms which move the door not like this, like a simple hinge, but like this parallelly. This is to make it safe, because this kind of door might hit somebody, because this is automated door now. In the case of medical and healthcare industry, nowadays you have lot of surgeries which are done through laparoscopic means, in which a small incision is made in the patient's body and a laparoscopic tool is sent through that. Now, when you want to do a surgery, you will not use normal scissors as we use, but these are laparoscopic tools which transfer or transmits the motion of the surgeon's fingers to the point where the surgery is taking place. So, you need specialized mechanisms for that. You need specialized mechanisms for assistive devices. There are people with certain disabilities, or after maybe a surgery, it is very difficult for a patient to get up from a lying down position to a sitting position, or from a sitting position to a standing position. So, there are assistive devices which rely heavily on mechanisms. So, in this course we are going to discuss some fundamental issues in mechanisms with an outlook of applications to such devices. So, this will be a foundation course. We will look at kinematic analysis of various kinds of planar mechanisms and robots. I will show you how various analysis tools are used to, for example, find out the displacement relation between the input and the output. So, input can be an actuator or maybe the surgeon's finger in the case of a laparoscopic tool, and the output would be the motion of the end effector. We are going to look at displacement analysis, velocity analysis of mechanisms, motion planning of robots. So, how you can generate a path. For example, if I want to generate a certain path, how should the actuators move in order to generate this path in the case of a robot. And we will go a little more than what normal a course on kinematics deals with. We are also going to look at the forces that are required to perform a certain task. For example, if I want to apply a certain force, what should be the force, the forces that the actuators must apply. So, these are not dynamic forces, of course, these are the quasi-static or the equilibrating forces. So, with this course I expect that you will be empowered to analyze mechanisms, do kinematic analysis of mechanisms and robots, which lies at the core, at the heart of design as well. Once I have a mechanism, I should be able to analyze it, find out the velocity relations, the motion, the workspace, etc. And I should then go over to design. So, the heart of the design problem for such devices is the kinematic analysis, and that is what we are going to look at in detail. So, I expect that with this course you will be empowered to carry out kinematic analysis, and this course will also pave way for more advanced courses on robotics and mechanism synthesis, etc. So, I expect you to come on board and enjoy this course. Thank you.